This episode of the Drone Radio Show is presented by Ascent Aerosystems, the leader in coaxial drones for mission-critical operations. Learn more at ascentaerosystems.com.
And the UAV ARC's job is to recharge drones en route, recognizing that drones have two limitations, which are frankly the same limitation, the range and payload. If you can charge drones en route, you can essentially extend their range indefinitely.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello everyone, this is Randy Goers, and welcome to the Drone Radio Show podcast, episode 305. Can clean energy power our drones? For that question, we head to San Diego and speak with Desmond Wheatley, CEO of Beam Global, a CleanTech leader that produces innovative, sustainable technology for electric vehicle charging, outdoor media, and energy security. It does this without the construction, disruption, risks, and cost of grid-tied solutions. Desmond joined Beam as a consultant in 2010 when it was Envision Solar, and he has served as the company's CEO since 2011 and as chairman of the board since 2016. He has 2 decades of senior international management experience in technology systems integration, energy management, communications, and renewable energy. He has founded, funded, and operated 4 profitable startup companies and was previously engaged in M&A activities. In 2020, Beam announced the development of the UAV ARC, the first solar-powered drone recharging network, which provides en route charging for unmanned aerial vehicles. The ability to recharge on a network of UAV ARC products deployed on rooftops, undeveloped regions, or at sea, should dramatically increase the potential range and utility of UAVs. Each UAV ARC unit generates and stores all its power from renewable sources, so drones will receive clean, renewable electricity with no cost per unit of energy. The units are completely independent from the power grid, allowing them to provide charging during grid outages or in remote locations. In this episode of the Drone Radio Show, Desmond talks about Beam Global, its patented CleanTech solutions, and how the UAV ARC is poised to support the drone delivery industry. But before we hear from Desmond, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. So let's find out how a CleanTech solution can power delivery drones with Desmond Wheatley of Beam Global. Let's pick up the interview where I asked Desmond to introduce himself.
My name is Desmond Wheatley, and I am the president, CEO, and also the chairman of the board of Beam Global.
Desmond, tell us about Beam Global.
Well, we're a San Diego-based sustainable technology innovation company. It's a bit of a mouthful, but what that means is that we invent, design, engineer, patent, test, and then actually manufacture renewably energized products for 3 market verticals. And those are the electrification of transportation, energy security, and outdoor media. So we essentially come up with clean technology solutions for problems and opportunities that have been around for a while. We take those through the patenting process, and then we actually manufacture them and sell them to our customers to solve their problems.
How long has the company been around?
It was originally incorporated in 2006, but I got involved in the first quarter of 2010 and then completely reorganized the company when I became its CEO in the third quarter of 2011. So we're really a 2012 and onward story.
Of the 3 verticals that Beam Global specializes, where do drones fall?
without a doubt in the electrification of transportation, which is frankly our main area of focus. The energy security aspect of our business is almost an accidental byproduct of our ability to convert renewable energy sources into electricity and then store that electricity very reliably, making it available primarily to power electric vehicles of any sort, but also as a secondary and emergency source of power during blackouts and brownouts and in locations where it's just not feasible to extend the grid. And then the outdoor media side of our business is actually more about funding the deployment of large volumes of our electric vehicle charging infrastructure products. It's more of a business model revolution than a technology revolution.
When talking about the electrification of transportation systems, some might automatically go to batteries, but that's not necessarily what Beam is doing.
Batteries are an important part of what we do, and they are an important part of the electrification of transportation in general. But it's important to remember that batteries do not generate electricity, they store electricity. Somehow, you have to have a source of electrical power that you can use to energize these batteries, which then redispense that power to whatever mode of transportation you're interested in powering. So our business model is about figuring out how to get energy into the batteries in the electric vehicle in a way which is not disruptive, is rapidly deployed, does not rely upon the utility grid as our sole source of fuel, frankly, moving into the future, and in a way which is much less expensive and time-consuming than the process which is required to connect to the grid. And often, frankly, in a way which is the only feasible way to get electricity to a location where you want to charge a vehicle.
So what's the source of power that you're using for drones?
We have found that the most reliable, the most forecastable, and the most convertible source of renewable energy is solar power. Even in environments where you might think that it's not a very good solution, it turns out that the technology has advanced to the point where if you use very high quality components and very highly engineered products like ours, you can actually extract enough solar power and convert it into electricity to provide a meaningful charging solution for most forms of transportation, even in places where the weather is, far from ideal. Certainly, we're based in San Diego, California, where we become used to relying on fairly nice conditions most of the time. But actually, New York City is our biggest customer for our solar-powered electric vehicle charging products from a city point of view. And of course, as everybody knows, New York in the winter, between the gray skies and snow and everything else, can be quite replete with inclement weather. And so we've demonstrated over many years that a properly engineered solar-powered piece of infrastructure can produce enough fueling power even in a place like New York. We also do integrate light wind into a couple of our products, but light wind is a much trickier source of renewable energy. It's much more susceptible to local and even hyper-local conditions. And so we use that in instances, on a couple of products where we can be confident that we're going to get fairly consistent wind, otherwise only in locations where we know we have a good resource.
Recently, Beam Global charged an aircraft with solar energy. Can you tell us about that?
It's just one of the most exciting and impressive things I've been involved with for a long time. We have a product that we call our EV ARC, which is Electric Vehicle Autonomous Renewable Charger. And it's really the most important word in that rather lengthy acronym is autonomous. This product is not connected to anything at all. It's not connected to the utility grid. It's not even connected to the ground except by gravity. And it's our top-selling product. And its primary use case is to charge sedans. Fleet, whether those belong to commercial or government fleets or other commercial uses, we sell these things across the United States and even a little bit internationally. to solve people's electric vehicle charging infrastructure requirements. Now, we became aware of a group of electric airplanes in the Central Valley of California. And in talking to the owner-operators of those aircraft, we found that lack of charging infrastructure was a significant barrier to their usage. It turns out there just isn't any charging infrastructure in airports. There are about 20,000 airports across the United States. There just isn't any charging infrastructure there. And beyond that, most of the smaller, about the 15,000 or so of the smaller airports, lack sufficient grid circuits, sufficient grid capacity to provide any sort of meaningful charging for aircraft. And of course, these lighter electric aircraft, most of them are landing in these 15,000 or so smaller airports, not the 5,000 or so large ones. So we determined to solve that problem by deploying our EV Arc, which is a construction-free, it requires no construction work, no electrical work, no on-site activity at all, in fact, and deploy that in an airport in Central California and do a test flight, frankly, to demonstrate this being aviation theory's only useful up to a point. We needed to demonstrate in practice that we could fuel this aircraft, fly it successfully, return to the airfield, and essentially refuel it without having any connection to the utility grid. And I'm very happy to say that in October of last year, we performed that test flight. It went off flawlessly. We were frankly very confident going into it because we did the theoretical engineering, but it's always nice to see the thing work. And actually, the story is a very nice full circle story. Myself and the pilot arrived at the airport. I was on an electric motorcycle. He was in a Tesla. We unplugged the airplane from the EV Arc. We plugged the motorcycle and the Tesla, both of them at the same time, to our product, our EV Arc product. We flew the airplane, which was full. We returned to the airport, unplugged the Tesla and the motorcycle, and left, having plugged the airplane in to find it full again the next time it needs to be used. So here's a fantastic example of a CleanTech innovation that's now providing power to aviation, clean, renewable electrical power to aviation. And I can tell you that was just act one, scene one in a much bigger story that we're going to be delivering during 2021. I can't go into the details on that right now, but stay tuned because we're going to do something really special this year with electric aviation.
Am I right to say that it's basically a charging station? Is that the correct term, or do you have a different name for it?
Yeah, it's a great question, frankly, because the industry's young, and as yet the terminology is not fully agreed upon. We tend to stay away from using the word charging station because, in fact, we are agnostic as to the provider of the charging station itself. Think of the charging station as the appliance which delivers electricity to the electric vehicle. It's an appliance like any other electrical appliance. It needs to be plugged into a source of electricity, just like a washer dryer does. And we're agnostic as to the provider of that. What we are, in fact, is a system which replaces the infrastructure that would normally be required to deliver power to that appliance. And so think of it like this. Normally, in that airport environment, to get power to somewhere where you could charge an airplane, you would have to find the nearest grid connection. You would then have to go through a lot of engineering and consulting and permitting and all sorts of other stuff. And of course, in airports, it's even more complicated. You have FAA and various other things to consider. And many of those airports, nobody wants to be digging up the tarmac in the airports because it's just a really expensive and cumbersome, much more so even than in the normal parking environments which we operate. Then you would extend the grid by laying cables in a trench. You would put some sort of pedestal-mounted appliance that the plane could plug into. That would require concrete and all kinds of inspections. It's just a lengthy and cumbersome process. Our product replaces all of that work. So it replaces the requirement for construction, for permitting, for electrical work, for engineering, for concrete, for trenches. And so what we're actually doing, you could think of it like this. The appliance fuels the aircraft. Our product powers the appliance. And we're just essentially removing the 100-year-old model that's normally required to connect something to the grid by using a CleanTech innovation product invented and developed and manufactured in California. It couldn't be more appropriate, frankly.
And the source of the power is solar power. Is that right?
That's exactly right. It turns out that even with a product which fits inside a standard legal size parking space, as the EV Arc does, we can convert enough sunlight into electricity and store it in the product. All of our products have onboard storage, so you can use them day or night or during periods of inclement weather. And it turns out that we can convert enough sunlight into electricity to power, to put it in terms of a sedan, we can power, let's say 250 driving miles in a day from a single parking space of solar. And where the aircraft is concerned, the mileage is obviously calculated differently, but nevertheless, having these products dropped off in these light airports across the country will allow people to essentially maximize the range of the electric aircraft, which today is still relatively small, relatively low, but increasing all the time. And island hop anywhere they want to in the country, just popping from one of these solar-powered products to the next, having a cup of coffee and a sandwich when they land, and then carrying on their trip. So it's a way of providing this sort of source of power, again, without construction, without requiring the grid. And by the way, crucially, as you know, the grid is prone to blackouts and brownouts. Our products, of course, are not. We will continue to charge transportation, whether that's drones or fixed-wing aircraft or 2 wheels, 3 wheels, 4 wheels, or even 18 wheels. We will continue to keep that transportation moving even during grid outages, blackouts, or brownouts. So you could think of us in a way, we have a strategic petroleum reserve in the event to make sure that we never run out of diesel or gasoline. You could think of us as the strategic electric reserve, that when the grid goes down, we'll keep transportation moving.
Does the system provide any efficiencies?
Well, let me be clear about what we mean by efficient. So first of all, the charging experience is just the same as if it were connected to the grid, because again, we're just powering the appliance that does the charging. So I suppose another analogy might be if you own a cell phone, you've got a little block charger that you plug into the wall. It's that thing which charges your cell phone. So we're not doing that. What we're doing is delivering power to that charger. The efficiency from that point of view is the same as if it was connected to the grid. However, of course, the great efficiency is that because we generate and store our electricity locally, we don't have all the inefficiencies associated with large-scale centralized generation and the transmission and distribution infrastructure that's required to deliver electricity from a power plant, whether that's coal-fired or natural gas or nuclear or whatever else, through the large transmission distribution infrastructure that you see in your daily life and to the place where you would charge the vehicle. We don't have any of that, because we generate and store the electricity right where the vehicle takes it. And frankly, that's a very significant improvement in efficiency. And then ultimately, of course, we're using an entirely renewable source of energy. So it's hard to get any more efficient than that. We're wasting it all today as a species. What we're doing is we're picking some of it up and putting it to use, which is sort of arguably the most efficient thing you could possibly do.
What's the intended market for the UAV Arc?
So we so far have two areas of interest for the new product that we have, the UAV Arc, which is essentially the same technology as our EV Arc, which is designed for vehicles. The UAV Arc is a different form factor, but it's the same thing. This is what we just got a patent on recently. And the UAV Arc's job is to recharge drones en route, recognizing that drones have two limitations, which are frankly the same limitation, the range and payload, right? Which is two ways of saying the same thing. If you can charge drones en route, you can essentially extend their range indefinitely. I mean, from a point of view of the charging anyway, you can extend their range pretty much indefinitely. And so our idea here is to look at applications, both commercial and also military, frankly, and say, how can we keep drones in the air performing their useful tasks for longer and without having them home run to some source of power? And the way to do that is to deploy UAV Arc in a network in the same way that we deploy the EV Arc in a network for cars. So these UAV Arcs will not go in parking spaces like the EV Arc does. These will go on top of flat roofs, on a hillside, on a mountaintop, in a field. We even have a marinized version within our design, which is GPS stabilized, remain in the same location at sea, so that, for example, submarines can launch drones and do not have to remain on the surface while the drones are doing their business. The drone can land on the marinized UAV arc, refuel, exchange some data, and then carry on doing its vital task, greatly extending its operational capabilities. In the case of package delivery, for example, we could take these drones, which are currently sort of sub 15-mile range, and make them able to perform a number of tasks without ever going back to the home base, because they'll be able to island hop and refuel from the UAV arc in a network. So, for example, if you think of a city like Los Angeles, these things could be deployed on top of rooftops, flat roofs, and drones could pop in, pick up some fuel, exchange some data, and then head off on their way. Doing that as often as they need to cover the distance that's required by the task at hand.
Can you describe how it might function in the real world?
What we picture happening is, let's imagine for a moment that you have we could talk about package delivery, because it certainly is one of the major areas of focus and one of the areas that we think we'll see the greatest growth. Currently, you can carry a package of a certain weight for a limited distance. And so that means you have to launch the drone within some fairly limited distance from its destination. And one of the ideas about that might be, for example, driving a van into a neighborhood and then having the drone do the final sort of small number of miles or yards deliveries. UAV arc deployed in the same area would allow the drone to go directly from the depot. You take the van out of the picture, and what would happen is the drone would leave. After a period of time, its batteries will start to get low. And at that point, it's going to autonomously route to the closest and first available UAV arc. It's going to land at that UAV arc. It's going to refuel inductively, so there's no physical plugging in or anything like that. And then while it's there, we're taking a look at that drone too. So imagine, for example, it's a 6-rotor drone. We're having a look at the drone, and if we notice that one of those 6 rotors is hotter than the other 5, we're capturing that data and we're making that available to the operator of the drone as part of the same sort of fuel/data subscription. And so we can gather data in a couple of different ways. First of all, during the charging process, if the drone allows it, we can gather data internally. But whether or not the drone allows it, we'll be able to look at state of health of the drone when it lands and even the package, state of health of the drone, state of health of the package. And this, of course, has fantastic safety implications, because a rotor overheating might be an indication of a failure. Certainly going to help with your maintenance scheduling if you get that information. But beyond that, we may be able to avert an accident with the drone. Similarly, if the package is in a deteriorated condition, we might be able to avert a situation where packages drop from drones in the future. So there's a whole host of benefits that come from this. It's not just about fuel. It's about situational awareness, essentially about the fleet of drones that are in operation. But then also, and crucially, I guess the core thing is dramatically increasing the range and therefore payload that these drones are able to carry. Because in the future, we think that the drones will be the mode of delivery rather than the sort of something intermodal in the middle, and then the drone doing the final mile or the final yard.
When you talk about the data transfer, what type of data is that?
I mean, one of the wonderful things about this business is that we don't even know yet what the full extent of this data gathering and exchange will be, just as nobody does. It's a sort of an Internet of Things situation. Now, it's as broad as the human imagination, really. We are certainly in the early days going to focus, obviously and appropriately, I think, on the safety aspect. So the first thing to do is make sure that we can give a drone a bill of clean health before it leaves us and goes on its way. And even monitoring the difference between a drone when it lands on one of our units and then island hops across to the next one. Has something changed? That could tell you a great deal about what's going on with the thing from a safety point of view. But you're quite right. As these things develop, there will be so much more that we can gather and share either with the subscriber to the network, or with the authorities about safety, or with third parties who are interested just to understand on how things are moving around and where they're going and when and all that sort of stuff. I daren't even consider the possibilities yet. But the thing that's certain is having the network in place and having the infrastructure in place, and doing that without construction without electrical work, without permitting, without worrying about what happens if the grid goes down when you've got all these aircraft in the air. These are all the primary motivators for us at the moment. And then, of course, once that's sorted out, then we look at all the other benefits that can inure to the infrastructure.
How large is the unit that you're producing today?
So that's currently dependent upon the device that's going to use it to recharge. And at the moment, we're very focused on the recent FAA ruling, which is essentially allowing Amazon to move parcels of £5 or less around. I mean, it's much more complex than that, but that guides a great deal. So the first thing to note is we're not talking about the sort of fixed wing aircraft that you may have seen. These will definitely be VTOL type aircraft that have to be capable of vertical takeoff and landing. And so we will right size the UAV arc for the application, just as we do with our other EV charging products. So we're not going to create a renewably energized EV charging product for a sedan and then expect it to charge an 18-wheeler. We have a different product for 18-wheelers. And in the case of the drones, in the early days, we will concentrate heavily on drones which are right-sized to do that type of package delivery that the FAA is already approving. And then as we see other markets grow and develop, then we will right-size infrastructure for those vehicles as they gain, usage.
Without getting too technical, is there anything about the system that we should know?
What's most important for us is that we maximize energy density in a small footprint. And again, this is the same thing with electric vehicles of the wheeled type as it is with the UAVs. And so what we're doing is we're doing things that, frankly, we wouldn't do if we were just, trying to create solar power at utility scale, for example. So we're throwing everything and the kitchen sink at energy density. And so that means tracking the solar modules using our patented tracking solution. That means maximizing the energy density in the storage, even in conditions. And remember, we are deploying these things in conditions where the temperatures, for example, variances in temperature are very, very severe. And yet these products that we're making are really Goldilocks products. They like the temperature that's not too hot and not too cold. And so making sure the thermal management on the storage, the electronics, and the generation is controlled is a key component of what we do. We're heading for 10 years into this, so we've learned an awful lot, I can assure you. So it's mostly that. It's about having a device which will operate in the broadest environments and conditions, meteorological conditions, and yet operate reliably and in the most energy-dense package possible.
When I was preparing for this interview, I learned that you joined Beam in 2010 as a consultant, and that led you to take on the role of CEO. What did you see as a consultant that made you decide you wanted to make a larger commitment?
Back in the first quarter of 2010, the company had a very different business model than we have now. As I mentioned earlier, we're really a 2012 onward story. It took me from the time I joined as a consultant to that third quarter of 2011 to re-steer the ship, if you like. And what I saw at that time was that I believed that the electrification of transportation was going to be one of the biggest paradigm shifts in human history. And that sounds like hyperbole, but if you imagine a world that will go within the space of a couple of decades from being fossil fuel powered, using oil-based products to run transportation, to being entirely electric, you can see what I'm talking about. It's a massive, massive paradigm shift, and one that's very much to the benefit of everybody, by the way. You don't have to care about the environment. It will create great wealth. It will create great benefits for consumers, governments, and geopolitically in every sense. So I looked at this back in the third quarter of 2011, and I said, we need to figure out how to get around the horribly onerous, time-consuming, and expensive process that's involved with digging up streets and doing trenching and concrete work. Because I've done a fair bit of that in my life. And frankly, every time I do it, I swear I'll never, 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 never do it again. And so what we did is we just sort of steered the company on a path of producing products, CleanTech products, which could solve these 100-year-old problems. And as soon as I got the board's approval to do that, that's when I said, now I'm going to throw my hand into this thing. They had asked me to join as a full-time employee from day one. But frankly, I wasn't keen on the existing business model. It wasn't until the board at that time approved transition to this new business model that I agreed to throw my lot in. And I can tell you, I don't have a full-time job here. I have 4 or 5 full-time jobs, and I love every one of them. Nothing I've done in my life, and been fortunate enough to have a very varied background, but nothing I've done in my life have I enjoyed nearly as much as building this company, the fantastic team that we have, and the innovative and unique and protected products that we have, and solving the problems that we're solving.
Then, of course, after 2012, the commercial drone industry really began to ignite. How did you see Beam Global position itself as the drone industry grew?
We wanted to have first mover advantage. We looked at drones, we looked at electric sedans, electric motorcycles, buses, 18-wheelers, the whole thing. And we thought, this is going to happen. And when it happens, it's going to happen huge. And when something like this happens huge, consumers and companies are far less patient than governments are. Governments will plod along. There's never been a consumer revolution that's plodded along. Think of cell phones, think of smartphones, tablets, PC. It doesn't plod along. It trails for a while. And then when it happens explosively. And there's a tremendous impatience to get the infrastructure in place to support the services and amenities that these new technology solutions require. And that was the thing that excited me the most. I was convinced that electric vehicles would take off in the way that they are now. Look at Tesla. Look at the fact that there will be an all-electric Ford F-150 later on this year, just the same as the diesel and the gasoline one, except it's not to 60 in 3 seconds, never goes to the gas station, and requires no maintenance. It's a revolution that the consumer will thrust forward again without patience. And so we knew that we needed rapidly deployed and highly scalable infrastructure solutions. The very same thing with the drones. We believe that drones will take off in a very dramatic way. Yes, the technology has advanced a lot in the last couple of years, but the compliance environment is dragging. But there'll come a time, and I believe it won't be long, when those problems are solved. And then the economic benefits and the consumer benefits and the efficiencies and everything that we'll get from mass deployments of drones doing not just package delivery, situational awareness. I've seen some of the fantastic interviews that you've already done with the oil and gas industry and others. There's going to be an explosion, a proliferation of drones. And when that happens, that will require a proliferation of fueling infrastructure, recharging infrastructure. And we have the fastest deployed, most scalable and most robust solutions available today. And they're well protected with our patents and other IP protection.
What advice would you give to other entrepreneurs in the drone industry?
Find something that's going to be really big and really complicated and make it simple. And do not give up until you succeed. I know that sounds awfully cliched, but the fact is the greatest things, the things of most value, are never easy. So find something big, something complicated, make it simple, and don't give up until you succeed.
Is there anything that we missed that we should talk about?
One thing we're fiercely proud of, and my accent may not suggest this, but we're very, very proud of the fact that this is an American company. We create the technology innovation, and then we actually manufacture the products in our factory here. And our team is the most diverse and wonderful team that you can imagine. Combat veterans, disabled workers, immigrants, people, frankly, as I say often, we're a meritocracy, but I believe we seek out merit in places that others fail to look. And if you came here, and by the way, you're welcome to as soon as this madness is over, if you ever find yourself in San Diego, please come and visit us. The two things that people are always impressed with when they leave here is, number one, the products. They just can't believe the products until they've seen them face to face. And the other thing is just the energy and diversity in the team here. And those are the things that I'm most proud of.
And for my final question, Desmond, what message would you like to leave regarding the future of unmanned vehicles that are powered by clean energy?
I mean, the message is it's essential that they are powered by clean energy. We're going to see, as I said, proliferation of them. What we can't do is add a new destructive and extractive load onto our current ecosystem, environment, global capabilities. We can't add new geopolitical pressure. We can't add new economic pressure. All of these new technologies that we and others are developing should be designed to make people's lives better, make them richer, create wealth, but do it in a way that is constructive, not destructive. And that's very much what we're focusing on.
That's it for episode 305 of the Drone Radio Show. I hope you enjoyed hearing from Desmond Wheatley of Beam Global and learning about clean energy solutions for drones. I want to thank Desmond for taking the time to speak with me. If you want to learn more about Beam Global or want to connect with Desmond, check out the website at beamforall.com. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Gores.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.